So we now welcome to the stage Mauricio Rojas presenting the power of Kubernetes CRDs to automate the underlay network at the edge via GNMI/Yang. That's a long title. Certainly a contender here. Mauricio is the principal consulting engineer for network automation at Nokia and is coming to us today from Texas. This is Mauricio's first time presenting at NANOG, and it's a pleasure to have him here today. So please, welcome Mauricio.
Thank you. To explain everything in the title, saying, well, we are working with CRDs. That is a new concept in Kubernetes. And also with GNMI and Yang devices, that is something also relatively new with network devices like switches and routers. Okay. Then I'm going to explain a little about the edge. Probably many of you are familiar with the concept. There are some use cases for the edge, like 5G. 5G was actually thought in the concept of microservices, that you can take some of those microservices closer to the user, like, for example, the user plane at the edge. You have other use cases like Cloud Run, that is being split also in microservices. You have the distributed units that can be talking with the central unit that can be also at the edge, in other edge, a central edge, or we can talk about the distributed unit at the far edge. And you have the radio units on the left that you need to also be communicating directly with the distributed units. For cable operators, you have applications like a PNG, CMTS, and so on. There are many applications that can be running at the edge to bring a better experience to the user and to the enterprises. What is the edge cloud from the point of view of where it's located? It can be located in what used to be a central office for the public telephone network. Could be also a coffee shop. Could be in the airport. Could be in a retail store. Could be on a head-end for the cable operator. Could be anywhere. Everything depends on the use case or the application that this edge is going to have for the carrier, for the operator, or even for the enterprise. Something in common on those locations is they're very limited in space, very limited in power. Then you can think on something bigger than probably 3 racks, or even sometimes a couple of devices like one server and one switch. You are constrained from the point of view of resources. Then anything that you're going to be running on top of that, need to think that you're going to be limited. Okay. Then how the edge is working and how we are trying to bring services on those locations. We have orchestration platforms like Kubernetes. Kubernetes today is present in the 77% of the cases, and it's growing. You need an orchestrator to bring compute, storage, network at the edge to make it agile from the point of view of bringing all the connectivity that those applications are going to need. Let's go for the case of Cloud Run, that you have the distributed unit, the DU, that need to, on the right, to communicate with the CU, and on the left, need to go to the radio units also. Then you need something that can bring the connectivity to the applications from the point of view of the underlay network. They need to be very agile. Need to be efficient. You don't have so much room for more servers. Then anything that you're going to bring from the point of view of orchestration and automation cannot have an independent platform. You need to work what you have at the edge, and sometimes it could be just one server and just one switch. Need to be self-contained from the point of view that if you lose the communication with your central location, you need to keep attending users, collecting information, waiting for this communication to come back. And that means that any sort of orchestration automation need to work independently from the central site. Performance, well, you can run different sort of applications. If you are, for example, running telco applications, like in the case of a packet core, you need to deal with performance. Or you are running applications that are related to a gaming use case, you're going to deal with latency or bandwidth. Then you have to run many different applications that they're going to require different things from the network, and your orchestration need to bring that kind of things. Then what we are doing with the CRD, well, first, we are limited in space. It's a very small footprint. And unless you have the underlay network covered, you are not actually bringing an end-to-end experience from the point of view of the orchestration and automation. That solution, because of the small footprint, need to run on the same, we are proposing to run on the same Kubernetes cluster as another application, like some sort of controller. You are limited in the amount of resources in your organizations to automate things. Means right now you have Kubernetes, and there are many tools that can work with the Kubernetes APIs. But in some cases, some applications for automation requires other set of tools, other set of APIs. Then the idea is to try to keep this simple using the same resources that we have at the edge, like Kubernetes, and only extend the APIs using CRDs. Multi-tenancy is sometimes the edge is not just for one use case. You have multiple applications with different use cases at the same location from different vendors. Then you need an application that can work on different namespaces, can actually be connected to different network services related to different users and different vendors. And the day two is anyone that knows very well Kubernetes knows that you have the scheduler. And the scheduler is taking the applications around the cluster, and it's very dynamic. And the applications, they can pop up in any node, anytime. Then you need something that can be related to that, checking on the events, how those applications are moving around, and start setting the services that those applications are going to require. Then, for that, we are proposing the use of CRDs in Kubernetes. That is going to help us to take advantage of that platform. I'm going to talk a little more about it. In something very common, and all those use cases, almost everybody's using multi-use. Who is not familiar with multi-use? Multi-use is bringing the possibility to create additional network definitions on Kubernetes. That means you have, for example, a data plane as a network function on Kubernetes, and this is going to require probably 10 or 20 interfaces. You need to create those interfaces using something like multi-use. That is part of the orchestration that you can bring from Kubernetes. But when multi-use is creating interfaces, you can deal with different technologies. In some cases, you have something called SRIOV, or MAC VLAN, IP VLAN. Then you need something, a controller that can not only work on the CRDs, but also need to be worked with the different CNI plugins that multi-use is going to start using to create the different network attachment definitions. Then this is a CRD. Starting in the release 1.7, we have the concept of CRD. We can create a specific object in Kubernetes for a specific application. In this case, we are proposing to use those to create a CRD that could be related to a switch or a router with the different pieces of the configuration that you're going to need on that underlay network. Okay. Then what we are doing is we are using Kubernetes as our platform for the controller. We are taking advantage of the APIs. Like I told you, the CRDs are helping me to extend the APIs of my controller directly on the Kubernetes APIs. Then I can keep using the same CI/CD tools that I have for my pipeline. Also, using other concepts in Kubernetes like the etc database for the values and to save the state of my CRD or the configuration that I have on my switches. I can use also the concept of multi-tenancy with the network, with the namespaces. I can use the security, the granular security that Kubernetes also is bringing on the table. And that is that controller that is going to be running on the, in our case, we are proposing to run this on the master node or controller node in Kubernetes. It's going to be working with the routers and the local switches through GNMI to do any sort of configuration that I'm going to need from the underlay network. Okay. Like I told you, using the CRDs, you're only extending any setting on the switches or routers directly on the Kubernetes APIs. Then as soon as you do any change on those CRDs, the controller is going to go and reconcile that information directly on the underlay network, on the physical devices. Thanks to that, you can use the same tools that you have for those APIs for your CI/CD process. In our case, for example, we were testing Argo CD to change the values of our Helm chart. Also, we are providing important information from the point of view of alarms in Prometheus. We have an instance running on the Kubernetes with Prometheus to bring all the information of any alarm, and FluentD also in Kubernetes to bring all the events that are happening in the controller and also in the devices that are local to that edge location. And you can connect this with any assurance management solution, or even with the Grafana or Kibana that are actually very used nowadays. For who is not familiar how Kubernetes is working, we have two different types of nodes. I'm going to spend just 3 minutes on this. We have the controller or the master node that is running the controller manager service that is actually a Kubernetes system application. It's like the actual controller of everything. And you have the scheduler. The scheduler is helping me to, when I'm going to create an application, is based on the information or the values of the workers, is creating the pod of that application in any of the nodes in the cluster. And sometimes it could be based on the availability of resources that I have in that node. And you have the API server. That's another set of pods that are running on the controller to bring access to Kubernetes. And you have the etcd values database, where all the information of my CRDs are actually saved over there. And as soon as I'm doing any change, the controller is taking that information and reconciling the information directly on the underlay network. But etcd is actual Kubernetes system application that is running on the controller. You have also the worker. The worker is the actual node where my applications are running. And you have kubelet that is taking care of overseeing what is happening with the container runtime. Some cases could be containerd or could be Docker or could be cryo. Everything depends on the technology that you are using. We are not limited to any runtime in this case. You have kubeproxy. Kubeproxy is the one that is changing the rules, security and network rules, directly on every worker to allow the communication with the different pods. We have the CNI plugins. Well, CNI plugin, you have many. It's just a standard where a vendor wants to create any sort of way to communicate the pods, for example, for the management interface. You have CNI plugins like Calico. Calico is very used in Telco. It's working with a layer 3 approach. But you also have Flannel, that is a layer 2 approach. But you have many different options for the CNI plugins for the management interface. In the case of the additional interfaces, we are working with Multiuse. And Multiuse is allowing me the way to create additional network definitions where I'm gonna put the different additional interfaces on my network functions that are running on top of Kubernetes. And usually I'm moving between IP VLAN, MAC VLAN, and SRID, between those three. How the controller that we are proposing is working in this environment? Well, we have two operators. One operator is running in the master node is the intent operator. The intent operator is collecting the information that we are of the CRDs, and depending on what changes we have in the CRDs, is reconciling that information directly on the switch or router through GNMI. I'm going to show later an example of the CRD, but you can see that actually inside the CRD, on every CRD that we are creating for the demo, we can define a specific path of where we want to change the configuration of the switch or the router. You have also the scaler. The scaler is the one that is going to do any change on the switches related to the pods or the applications, how they are moving around. I mean, you have an agent in the node, in the worker node, called scaler agent, is overseeing all the events that I'm having in those nodes to see if there is any new application on the nodes that is requesting a specific network definition that I have created with Multiuse. As soon as I'm creating that application, or this application is popping up in any of the workers, you don't know exactly where it's going to happen, depends how you set up the values of the workers and how the scheduler is actually using it. It's going to go directly to the operator on the controller and say to the controller, well, this new application with those interfaces, I need that switch actually to be connected, and please create the VLANs on that switch or router and add those sub-interfaces directly to those layer 2 or layer 3 services on the network. Okay. Then sometimes you have applications that are running interfaces. For example, in the case of Cloud Run, you have multiple different applications and pods. Some of those need to go and connect with the central unit. Others need to go to the radio unit. Then this is the way that actually you can create many replicas of the application, and you're going to have something that is going to be overlooking where I need to do the changes on the underlay to keep the communication and do it quickly as possible. And lately, you have the network intent. This is an actual container image that you can run on your laptop when you want to build any Helm package chart for your intent for your deployment on the underlay network. And then you can take that information. It's just bringing some simplicity in the way that I can design those templates and then put those templates directly on my CI/CD tool. That could be, for example, Argo CD. This is, well, what is the value prop that we are bringing with this solution after all this technical description? Well, normally Kubernetes, the standard approach is, yes, I'm bringing orchestration to the network, but the orchestration is only at the level of the servers, at the nodes. Doesn't have any context of what is happening on the underlay network, on the switch or router that I have at the edge. Then, like I told you, this is not enough, is I need to connect some of those applications to other sites, like I told you, a central site or radio units. Then, what is the evolution that we are bringing on the table with something like this, with the CRDs in Kubernetes and the controller, is now I'm bringing all the context of the underlay network and the different services that I have through this underlay network to connect the different other sites directly to Kubernetes, and I can manage everything directly using Kubernetes APIs. And then I'm using Kubernetes not just like the orchestrator of my applications, I'm using Kubernetes now like the orchestrator of my whole network at the edge. Then, having those in intents, I can take all of those intents along with the application. It doesn't need to be an intent specific for the network. I can put all together in the same Helm chart. The application, for example, definition, and also the network requirements in only one package. And I can run those in multiple edge sites and have this actually working through the APIs to orchestrate all the deployment of my edge and the different applications, even if I need to run this for different vendors. Then, what is the benefit of that? First, I'm providing an intent-based solution for the edge, where you can design your underlay network depending on the use case or your application in a intent format. I mean, in this case, in a Helm chart that is basically a YAML file or could be a JSON file. And I can put this directly with my application. Then it's only one pipeline investment that I'm doing along with my application to also take care of the network. And I want to have only one single source of truth regarding anything that I'm going to need at the edge. Then everything is going to be actually in this intent. And that intent is going to have a values file where I can customize everything from that point of view. What is going to happen in my organization is you have the concept of NetOps, and some of those are actually working as network designers. Those network designers, now anything that you're going to need from the point of view of the network can be done in an intent, in a file, JSON file, YAML file, like any piece of code. You can define all your settings for that edge directly on that intent, and then provide that intent using those CRDs that we are using with this controller to the operation that where they can change any of the values to customize those intents depending on the use cases that they need to bring at the edge. We have also cases that we have the application team that is also using those intents to create other services. We have a case with load balancers. We were actually working only in telco use cases, but someone was asking, well, I need to do a BGP relationship with the load balancers on my nodes, my Kubernetes nodes. And every time that I need to do that, I need to go and open a ticket with the network team, and it's taking me like a couple of weeks to get an answer back and I have that. Then in those cases, the network operation team can provide those templates and bring some flexibility to the application team to do all the changes that they need in order to start doing the BGP peering for the load balancer service and get a similar approach in the way that you're having on the public cloud, but now in on-premises. Then it's saving a lot of time. You can put different roles, and you have the concept of CDCI also bringing the agility that the edge is going to require. Then this is an example of an intent. It's a Helm chart. Then on the right, you have the template that is the one that actually is defining the CRD. Like I told you, the CRD is just a definition of an object. You just, in this case, the object is a piece of the configuration of the router and the switch. Then in GNMI, you specify the path where you are going to do the change and the values of that tree for the change. And on the left, you provide the different values, the input that you can use for that change. In this case, for example, I have the physical interface 1.1, and I'm defining 4 VLANs with some specific numbers. But in other cases, probably I need to use other sort of VLANs or more VLANs or less VLANs. Then I can provide this information directly on the values chart, and I don't need to touch the template, the design of the network. Okay? Then on the right, you have the network designers that they can create intent. And on the left, you have the network operators that can be modifying those values depending on what applications or what VLANs they are going to require. Okay? Here you have a screenshot of how we are seeing these changes in Kubernetes. Then the application team and the network operation team, they can see if those changes, those CRDs, actually, if they are working. You can see the path that actually of the configuration that they are changing on the switch and in the router. You can see if the process was successful. In some cases, the status is not ready. You can just go inside the controller and see what is wrong. Or you can go to Prometheus or FluentD and start pulling information through Grafana or Kibana to see maybe a bigger picture of that. You can go to every piece of the CRDs that we are defining with this solution. If you go, for example, this is one of the CRDs that you see before, then I'm just getting one of those elements, objects, and then just getting the description. You can see that actually you have something very similar of what I'm doing with GNMI. And just putting the path of what I want to change, and you have the values of the actual change that I'm doing in that part of the configuration. And also you're getting the state of that, is it working or is it not working. Every time, I can go to Kubernetes and I can do a change anytime of that CRD, and this is going to be reconciled immediately with the underlying network. I don't need to go all the way through only home. I just can go directly, for example, to that CRD and do a specific change manually, and that is going to be reconciled immediately also on the network. But this is going to be my single source of truth of what I have in my underlying network. There are multiple use cases. We've been working with some customers with proof of concepts. We have a proof of concept with Packet Core. We have a proof of concept with Cloud Run. We are working with different Kubernetes distributions. In some cases, it's vanilla. Some cases, we are using OpenShift. Other cases, we are working with Google Anthos. We are not limited in the type of Kubernetes that you can use for this. We are working through the APIs. Then it doesn't matter what kind of Kubernetes or runtime or container runtime you have. We have also a use case that is the enterprise hub network. In this case, the virtual The application is a security gateway. And this is the one that actually I got. I have a recording of the demo. I compressed the demo in 4 minutes video. I just want to show you a high-level understanding of the solution. But the funny thing of this is the security gateway also have a GNMI interface. Then I'm not doing just the intent for the underlay network. I also doing the intent for the actual security gateway that is an application running on top of the cluster. Then we're not just bringing the intent for, like I told you, for the infra. We're bringing the whole concept in an intent. Then for this demo, and this is an actual demo that we are doing with a customer. Actually, the customer requested to do this demo. And by the way, this is still work in progress. We are thinking to release the APIs to everybody to use it. And if everything goes okay, probably in a couple of years, we're going to release the whole code of the application to the whole community. But so far, we're going to start releasing the APIs. Then what we did is, this customer was requesting a solution because COVID, many of the employees were actually returning home and working from home. And at least in my own experience, when I have to go and start working from home, I was working in my lab and from the office, and I could just upload a container image in 2 minutes. Working from home, connecting a VPN from Texas to Chicago took me like 2 hours. Then you can see there is a big difference between working from office with a private link to your lab that working from a VPN that you actually using from home. Then we were thinking about many solutions. We have also SD-WAN, but the problem with SD-WAN, you need to invest in an appliance in every home, and you need to provide, even though a private link, because internet is not enough. Other solution that we were thinking is maybe we can go with a private link and as CPE directly at every home, but the cost of software, the cost of the appliance and not the link is very high. Then the solution that we were thinking with the customer is, okay, what about if at the edge, in one of the headends that I had on many of the cities, you have probably like 10 or 20 headends in every city for different residential areas. We can just bring a security gateway right there, and from there to create a link, a private link to the central offices with a VPRN or with MPLS. That could be a possible solution. Then we were thinking about this. Well, the limited space that we have in those places actually force us to go and think immediately about Kubernetes and think about how can I automate hundreds of sites with a security gateway solution using a controller like this. Then we thought in the virtual security gateway as a network function running directly on Kubernetes at that site, and then that is going to help me as a user to use any sort of application that can support IPsec to create a tunnel. I don't need a specific application. I just need to support IPsec and get the certificates from my organization, and that's it. Then what we did is we create a proof of concept thinking is, okay, I have the user, the home user from in one end. I have the central offices in the other end. And in the middle, I need to put the Kubernetes cluster with my virtual security gateway and get the connection from the user to that virtual gateway and then going from there to the central office. It was very basic. However, they also requested, well, I want that security gateway to also support multiple organizations and multiple customers. Then when we're starting to deal with that, we realized, okay, probably we need multiple interfaces. We were thinking first in just in a couple of interfaces, then sadly we were thinking in maybe 8 or 16 interfaces in the same virtual instance that was running in Kubernetes. Then we created a demo, everything virtual at first, and then we put our security gateway in Kubernetes, I think it's very small. Sorry for the small font. And we have an area at the top that is the security gateway with the certificates. And at the bottom, we have the VPRN that is going and taking me to the office. Okay. In the middle, I have the leaf that is an actual leaf at the edge. And I have also a border leaf or border gateway that is the one bringing all the services from the residential user and also giving me the access to the central office through an MPLS network. Then we simulate everything with containers and virtual wires. We thought, well, build something like that is good, but well, you know, there is some constraint to get devices, and sometimes it's taking months to get my full lab or the full stack of devices that I need to build that lab. And thanks to the technology of containers, now we can have switches, routers in containers. We can use virtual wires for the connectivity. Even Kubernetes can be running in containers using virtual wires to connect the whole thing. Then we use Container Lab. For who is not familiar with Container Lab, that was actually in a presentation, I think 2 nanox ago, where actually they brought a tool that is online that you can just download and create any sort of topology for your data center. In this case, we created a topology for the edge, but you can go with a 3-tier topology if you want to try to simulate a data center with that. Then we used the Container Lab. We created the Kubernetes cluster. We connected that with virtual wires in the same server. And we brought the security gateway as a virtual application. And thanks to that, thanks to the controller, the edge controller, we could create all the configuration, not just for the underlay network from the scratch, also for the security gateway through the GNMI access. In this case, we were working with just one replica, but demo can be extended to many replicas of the security gateway. You are not limited in resources from the point of view of a Kubernetes unless you have only one node. But if you have multiple nodes, you can create many replicas that you want. Again, sorry for the small font. You have here, this is the full topology that actually we created through the controller via GNMI. We created the security gateway, the VPRNs. We created this for different organizations, for different users. We did everything at the border leaf and also at the leaf that is directly connected to the servers. Everything from Kubernetes. We didn't touch any device at all, not even the virtual security gateway. The virtual security gateway also was fully set up from Kubernetes. And that took us only 5 minutes to be more exact. Then this is our recording. You're going to have a recording of this session, then you can go later step by step if you want to see it carefully. Sorry about that, but I just want to bring the whole, the high-level description of the video. Here you're seeing, and I'm trying to zoom in some of the pieces of this demo. You're going to see that I'm running Helm packages in my Kubernetes to set up all my network, all my underlay network. Then as you see here, I only have in my switches the management network first. And now after I run the Helm chart, I have also the layer 2 services that are going to provide to all my applications on the Kubernetes cluster. And then I'm going to start creating now my security gateway. When I create my security gateway, I'm adding 4 additional interfaces to my security gateway. I don't know if it's going to pop up in the worker 1 or the worker 2. This is why we have the agent that's going to do the job for me. This is machine to machine. I'm not actually deciding anything here. It's actually the machine, the Kubernetes and the switches are deciding where they're going to actually allocate the services. And then you see here, as soon as I created the security gateway, is the application through the controller create the sub-interfaces and allocate those sub-interfaces in the right interfaces. and then connect that to the right services, depending if I'm going to the user, home user, or I'm going to the central office. I want to also set up the security gateway, because I have my security, the appliance, the virtual appliance working, but now I need to set up my security gateway. I need to create, put the certificates, do the IPsec settings for the security gateway to work. And if you see in this testing, the home 2 is not working. The home 1 is the only one actually working in this. We did that at purpose, because now I'm going to go to the intent, and I'm going to start changing the values of my intent to also add the second home user, and I'm commenting the lines, and now I'm going to apply the chart again. If you're using a CI/CD tool, that would be happening right now, but I just wanted to show how we are applying a Helm directly through Kubernetes. As soon as I'm running the ending with the setup through Helm, with the new values that I put in my intent, you're going to see now the 2 users, now they have communication with the central offices through that security gateway. And that is going to happen now. Okay? Then the idea of this demo is to bring a high-level understanding of the solution and not just changing the underlay network. You can see now I'm actually checking the gateway like it was any sort of router. And also changing here the virtual function that is my security gateway, because I have also GNMI access to that device. Even if only a virtual function, I can do intents, I can apply intents of those devices. And you can see every piece of the configuration that I'm doing on those devices directly in Kubernetes. You can get the description of every piece of the configuration in Kubernetes, and I can do manual changes if I want through the APIs in Kubernetes, and they're going to be immediately reconciled with the fabric, or with the, sorry, in this case with the switches or the security gateway. Then this is my last slide. Well, if you want to see more information about the edge controller, like I told you, stay tuned, because we're going to open the project, the APIs, to anyone to download the images, the container images, and start playing around in your own Kubernetes. Also, I encourage you to go to Container Lab, because you don't need to have physical appliances to start playing with this solution. You can do everything virtual with a very low cost in compute and storage, thanks to the container technology. And there is a presentation of 2 Nanok ago of Container Lab that you can see all the detail of how you can set up a Container Lab. And we are also, in this case, for demo, we use SR Linux. We also support SROS. And for the ones that I have a question is, are you supporting multi-vendor? Yes, we are planning to support also other vendors, other devices. And we are going to add probably a operator for netconf. The only problem with that is the visibility that we can get with netconf in some of the vendors is very limited. Then we are only be able to do settings for the visibility, or for what the actually netconf is allowing us to do. Okay. Well, that's all, and thank you very much. I don't know if you have any question. Think we are good? Okay, thank you, Steve.
Thank you. Thank you. No questions from remote. So thank you, Mauricio, and for your time. Oh, we have a question, Mauricio.
So it's not loud enough. So anyways, regarding all those VMs that containers that you run under Kubernetes and everything, did you find a specific requirement to run anything like a SROV, or like tapping directly into the network interfaces and stuff like that?
if we have any requirement, if need to be SRV or need to be IPVLAN. Sorry.
Yeah, so you run everything with MacVLAN or SROV, or is there a big difference for you?
Okay, in this demo, we are running MacVLAN because we are doing this virtually. For SRV, we don't have any restriction with SRV. We can work also with SRV. But to do the virtual demo, you need actual appliance, a physical appliance, in order to make that work.
All right, thank you very much.
Okay, you're welcome.
Any additional questions?
Okay, thank you for the question.
Thank you, Mauricio.
Thank you.